computer, see how it works. Okay, welcome Jane and Christian, and hopefully a few others will show up too. This is week 2 webinar, and it's a kind of second take of it. We also did one last night. And the plan today is we're going to talk about chapter 3, and that's probability. I want to warn you that probability is a tough one. Probability is one of the toughest chapters. A lot of people think chapter 3 is the hardest chapter of the book. So you may or may not notice that for this chapter 3, we don't have anything else going on this week. There's no project due, no tests. It's just a single chapter. The reason for that is tough one. So expect it. It's not long, but a lot of students have trouble figuring out what to do. And what I hope is that by the end of this hour, you'll get to see lots of examples. Nicholas, thanks for showing up. So what I'm going to do is I'm going to show you lots and lots of examples. And we'll start out with some easy ones, and then we'll get harder. So if you find it really easy to start with, then just wait. It'll get tougher, I promise. So let's start out right here. Hopefully you can see this. Okay, and I'm going to mute you, Christian, because I think you had some background music, background noise, and that way we don't get quite the background noise. But if you do want to talk, unmute yourself, and then you can talk. That way we don't get that background noise that we've got. Okay, so we got a die here. This is standard. It's not a cheating dice or anything, but I have a couple of easy questions to ask. If I roll this die, what is the probability that it lands on a 6? Let's see if you can put in your chat box the probability that it lands on a 6. Again, it's not a trick question. If you have any idea, then you should get it right. Yeah, so the answer is 1/6. And I want to highlight something about the answer. It's really important. Notice the answer is a fraction. Okay, probabilities are fractions. And as you all know, I hope you know, that fractions have a numerator and they have a denominator. And when it comes to probability, the numerator and the denominator have real special meaning. The denominator of the fraction for probability are the number of possible outcomes. And as I hope you all know, when you look at dice, there are 6 sides. So the denominator will be 6 because there are 6 outcomes. This is a very easy example because I think not hard to look at the die and know there's 6 sides. Later, we're going to see where it gets really, really rough, where you can have a denominator in the millions, and we'll do an example of that. And then the numerator are the number of ways of making what you're interested in happen. So in this case, if you look at the 6 sides, only one of them, exactly one of them, is a 6. Okay, again, I'm not saying anything that should be confusing at all. You should know that there's one side that's a 6 and the others are other things. So notice because there's one side that's a 6, that means that the numerator's a 1. Any questions? So welcome, by the way, Amanda and Sonia. I see you came in, and I don't know who you are, 209-602-7454, but thanks for coming also. With the phone, it's always a little bit harder, and I do a lot of visuals, so hopefully when you're looking at it on the phone, you can see it too if you have a smartphone, because voice isn't quite enough for these. Okay, so that's an easy one. Probability that this lands on a 6 is going to be 1/6. What is the probability? Do a different one. Let me ask you one quick question. Are you all familiar with cards? I just want to make sure I don't do some example and you have no idea and you've never seen cards before. It's a cultural thing, so I just want to make sure in your culture you not necessarily are expert in card playing, but at least know cards. Everyone okay with that? So speak now or forever hold your confusion. Okay, because I could do other examples. Okay, so if I pick a card, what is the probability that this card that I'm looking at right now is a queen? See if you can put in the chat box what the probability is that it's a queen. Okay, and I guess if you don't have a chat box, I guess you have to say it. So it's a queen. So again, remember probability, you look at how many different outcomes there are, and how many makes the queen true, right? The number of total outcomes that could possibly happen, that's the denominator. The number of cards that make it true, being a queen, is the numerator. Yeah, any queen, so a queen, this means any queen you want. Okay, I see a lot of answers. I haven't seen the right one yet.
I'm not sure how many queens are in a deck. So
okay, yeah, so I thought cards, okay, so let me quickly describe decks. Okay, every value has 4 cards. So there are 4 queens in a deck, there's 4 sevens in a deck, there's 4 aces in a deck, there's 4 twos in a deck, etc., etc., etc. And there are 52 cards in my hand. There's 52 cards in the deck. So what is the probability that this is a queen? And you don't want to reduce the fraction. Okay, one is you might make a mistake. And the other is, I think if you don't reduce it, it's actually a little more clear on what's going on. So I'm still waiting for the right answer. I'm hoping for it. There we go. There we go. Amanda's got it. So the probability this is a queen will be 4 out of 52 because there are 4 queens in the deck, as we just mentioned, and there are 52 cards that could be chosen from. So that's 4 over 52. Any questions on that? Because I saw a lot of you were struggling on trying to get the right answer there. Any questions? I will let you know I don't test you on cards, okay? But I do test you on probability. So I'm not going to give you anything that you have to know anything about card games. But you do definitely have to know about probability. I could test you. Instead, I'd say, well, you got a box, and there's 5 green things in the box, and 6 blue things, and 3 yellow things. Find the probability. But I figure that's a little less interesting than cards. Okay, so I want you to look carefully. Everyone see that card? I know it looks backwards, but hopefully you can see it. And watch what I'm going to do. I'm going to drop it on the table. And now I'm going to pick another card. What is the probability that this card right here in my hand is a queen? What's the probability that this card is a queen? Okay, yeah, Kristen's got it. It's going to be 4 out of 51 because it still could be any of the 4 queens, but now you know it is not the 6 of spades, the one I dropped on the desk. Does that make sense to everyone? So it's 4 over 51. Okay, so next experiment. We're going to do a lot of experiments. And cards work well because they're just easy to see, very visible. Okay, so now watch carefully. Everyone see that card? Okay, what I'm going to do is I'm going to put it back in the deck. And then I'm going to mix the deck. What's the probability that this card is a 3? Notice that you saw the 3 of hearts, and I put it back in the deck. What's the probability that this card is a 3? Okay, I'm still waiting for the right answer. So try in the chat box, see if you can get the right answer. I'm still waiting. We'll get there. Okay, maybe I should tell you because I'm not seeing it yet. So the idea here is that because I put the other card back in the deck, this card could be that other card or any of the others. So there are 52 cards this could be because there's nothing ruled out because I did it what's called with replacement. Because I replaced the card I looked at, there's now still 52 cards left it could be. It could be any of the 3s. It could be one that I didn't see or the one that I did see because I put it back in the deck. We started over. So the probability is 4 out of 52. So let me ask, are there any questions on that? Because I didn't see it. Oh, you're imagining 6 on the table. Ah, I reshuffled the deck. Yeah, I reshuffled the deck. I guess you didn't see that part, but I said I reshuffled. Sorry about that. You can always ask, by the way. Yeah, so it's 4 out of 52 because it could be any of the cards because I put the cards back in and reshuffled the deck. Okay, any questions on this? Okay, so this is the basics of probability. They get harder. So ready for a harder one? So now I'm going to reshuffle the deck.
With all the cards, correct?
Yeah, they're all in my hand. And I'm not cheating. I won't do that. Okay. So now what I'm going to do is I'm going to pick 2 cards. That changes everything. So now what is the probability that the first card, this one, is an ace, and the second card is a king? So what is the probability the first card is an ace and the second card is a king? My guess is you're going to need a little help on this because this one's a bit harder. So the first is an ace and the second is a king. Okay, so I still have the cards, not doing anything with them, but I need to start typing. So I want to put in the chat box the key formula. And that's the probability of A and B is equal to the probability of A times the probability of A given B. So just note, hopefully you're looking at the chat box also, just note that that little vertical line segment means given the knowledge that that second thing occurred. So we're going to do this one little piece at a time. Let's start with the A. So what's the probability the first card is an ace? That should be easy for everybody. What's the probability the first card is an ace? Yeah, put it in your chat box. Yeah, that's 4 out of 52. Okay, so if you know this is an ace, what's the probability that this is a king? I think Nicholas has the idea, except he typed it on. Yeah, Amanda's got it. 4 out of 51. Okay, because there's 4 kings. If you know there's an ace, there's still 4 kings left. And there's 51 cards now because it's not this one. And this one we heard that this one was an ace. So there's only 51 left to be chosen from. So that gives you 4 out of 51. So now using the formula I gave you, let's see if you can type in the chat box. I don't want you to do the math. I want you to kind of write it out like the formula has. And see if you can write in the chat box the multiplication that gives you the probability that the first card is an ace and the second is a king. And let's see if you can figure that out. So if you can type in the chat box, what's the probability the first is an ace and the second is a king? Yes, 4 out of 52 times 4 out of 51. Any questions on that? What I'm not going to do today, because I'm going to assume you already know how to do this, is I'm not going to show you how to do basic arithmetic in the calculator. Are y'all okay with that? Okay, but you are responsible to have a calculator and you are responsible to know how to take 4 divided by 52 times 4 divided by 51. So I do expect you to do that. I'm going to show you the more difficult things in your calculator, but not basic arithmetic. So we're just going to leave it, and I think it's more illuminating to see as a multiplication than it is to just me to give you 3 decimal places of accuracy or something, which is not very meaningful for you. Any questions on this so far? Okay, this could get very difficult, by the way. I used to teach a class called gambling, statistics of gambling. And imagine if there's 5 cards. It gets much, much more difficult. So we're not going to do the really hard stuff right now, but you can imagine how hard it is. Any questions so far on these? Okay, so now we've seen an and question. I'm going to mix it up again. Okay, so now, what is the probability that the first card is a 2 or the second card is a 3? So I want to give you a key formula for that that's really important. So let me type it in the message box. So the probability of A or B, okay, the key word or is important before we had and, is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so the reason why this is true, you can think of saying that the first card is a 2 or the second card is a 3. So that'll work if this is a 2. It'll work if this is a 3. It'll also work if you have a 2 here and a 3 here. You see that? So if you add the probability of a 2 with the probability of a 3, we're double counting the 2 comma 3. And that's why we have to subtract the and. Because the 2, 3 got counted for this one and it got counted for this one. And we double counted it. And that's the reason for the formula subtracting. Okay, so now we got to figure that out. Let's do it piece by piece. I'm going to have you put in the chat box. What's the probability the first card is a 2? Put in the chat box. That's supposed to be really easy. Yeah, that's 4 out of 52. Okay, now comes the one that's tough for most people, but let's see if you can do it. What's the probability the second card is a 3? What's the probability the second card is a 3? Put in the chat box. So let's see if you can all put in the chat box. You got a couple guesses that are different. Okay. All right, well, it's a good thing we're not voting here because the answer is 4 out of 52, and let me explain why. Okay, we want to find out the probability the second card is a 3, period. Period. I did not tell you what the first card is. So I'm taking the first card. Do you all see this first card? And I'm putting it down. Are there any cards that you can now rule out? And if there are, you better be able to write down which card you're talking about. And you have to be very specific, like King of Diamonds or something. And the answer is no. There's no card that you can rule out because all you saw was the back of the card. Just because a card's been picked, if they didn't tell you what it was, it doesn't change the probability. Does that make sense to everyone? So that's why the probability that the second card is a 3 is still 4 out of 52. Because we didn't know the first card. So there's no knowledge. Knowledge will reduce the denominator. No knowledge won't. Any questions on that? Okay, then we got to find the probability of A and B. Okay, that one we basically already did in the last example, although I think I did it for ace and king, but 2 and 3 is the same. Is that clear to everyone? Doesn't matter which numbers I'm deciding, it's the same probability. So now we're ready to put in the chat box. Let's see if you can put in the chat box the, don't do the arithmetic, but the expression that gives the probability of the first being a 2 or the second being a 3. And let's see if you can put in the chat box the expression. And again, don't do the arithmetic, just write it out, because writing it out is a lot more enlightening than the number itself. The answer is very uninteresting. It's the expression that's more interesting. So let's see if you can put in the chat box based on what we just looked at. Give you a minute. Okay, Amanda, you're close. You're close. You started out nicely, but I think you forgot about the and problem. Remember, the and problem had a multiplication in it. Do you remember that? So you're really close, but there's an and involved. Yeah, 4 out of 52 plus 4 out of 52. So again, first is a 2, had 4 out of 52. Second is a 3, also had 4 out of 52. And then the probability of the first being a 2 and the second being a 3 was 4 out of 52 times, as Nicholas has, 4 out of 51. Do you remember that? Because with the and included the word given in the formula. Okay, and that came right from the last example. Any questions? Any questions? So look at Nicholas's post because that's the correct one. Megan, you were close, but you needed a 51 in that second denominator. Any questions on that? Are you convinced now, my warning, that this is a tough chapter? That you're going to be asked a bunch of questions and you're going to, the arithmetic is very simple, right? Basic calculator work, at least on this stuff. The hard part is knowing what arithmetic to do, knowing that it's a 51 in that last denominator, not a 52. Okay, things like that. And it's tough. It's tough. And the best way of getting good at this is practice, watching some examples and then practicing a lot of them. Any questions on the cards? Okay, so now here's a harder question for you. I know this was hard enough, right? Here's a hard question. What is the probability that within a week or so, I'm going to tell my colleagues I don't need my salary anymore, we can donate that to charity? And of course, you need a hint. You need a little context. And here's the context. Everyone know what that is? Okay, what is that?
Lottery ticket.
Yeah, it's a lottery ticket. So again, if this wins, my salary will be donated to charity. I'll be fine with that because I will be so rich that I'll be okay with it. But I don't think I need to tell my boss quite yet. Okay, seeing that I just got this ticket. Okay. One thing you may be able to see or may not, if you look really closely, there are 3 sets of numbers. There are 3 sets of winning numbers. I like to buy 3 tickets. So the one ticket has 3 tickets involved in it. So the question is, again, what is the probability, in simpler terms, that I win, that I'm going to win the lottery? Okay, that's hard. I don't expect you to put that in the chat box, by the way. Okay, that's a lot of work. So the first thing is you have to know how to play the lottery. Does anyone know the details of how to play the lottery? This is, by the way, Super Lotto Plus, because every lottery is a little different. And my guess is you don't, which is okay, because, okay, unless I see a yes, but I doubt it. I don't think I've ever had anyone know exactly. So I'm going to screen share, go to what we need to know. And that is the California Lottery site. Okay, so here's the how to play the lottery, because that you need to understand. Okay, so first, basically, buy a ticket. I'll let you read through that first part. And then step 2. Step 2 is the important one. Pick 5 lucky numbers from 1 to 47. And then 1 mega number from 1 to 27. Okay, and then what happens is the lottery officials are going to pick 5 numbers from 1 to 47 and 1 number from 1 to 27. Okay, one thing you may or may not know, I don't think it actually shows it, but I definitely know it's true because I've researched it, is that the 5 numbers from 1 to 47 that the official picks are different numbers. They're not going to pick the number 3 twice. On the other hand, the mega number from 1 to 27 can coincide with any of the 5 numbers. Okay, so the reason why I'm bringing that up is we have language for this. So what we can say is that the 5 numbers from 1 to 47 are picked without replacement. So they're picked without replacement. But the numbers from 1 to 27, that number is picked with replacement. So those are important statistics words. And whether it's with or without will change the answer. So you always have to know the rules. And that's the rules of the lottery. Any questions on that? Okay, so one more thing to look at, and this is very similar to the and question, is that because it's with replacement, what we can say is the probability of getting all the 5 numbers and getting the mega number is going to be equal to the probability of getting the 5 numbers times the probability of getting the mega number. Any questions on that idea? So what we're going to be able to do, if we see all the different possible numbers that can be picked, we're going to count first how many numbers there are from 1 to 47, how many 5 numbers there are from 1 to 47, multiply it by 27, because I think you all know, hopefully, there are 27 numbers from 1 to 27. That's not a very tough question right there. So we're going to multiply the number of ways there are of getting 5 numbers from 1 to 47, multiply that by 27, and that'll be the denominator. Any questions on that so far? The numerator is actually quite easy. So the numerator is how many ways there are of winning. And remember, I showed you my ticket. Okay, and let's see. Whenever I'm screen sharing, it's really hard for me to find the chat box. That's in here somewhere. There it is. Okay, so what is the numerator? You can put that in your chat box. Now I can see it. And the hint is it's very, very easy. I promise you it's easy. But you need to know what I showed you on the lottery ticket. Nothing hard on it, but you need to know what I showed you. You don't even have to read the numbers, but remember what I told you about it. I don't see you all typing. Any thoughts? Still waiting? I guess not. Are you confused? Okay, well, I told you I got 3 tickets, right? There's 3 lucky sets of numbers. So what's the numerator? 3. 3. Okay, because there are 3 different ways that I could win, and that's for this first row to win, the second row to win, or the third row to win. And that makes me win. Any of those win, because there's 3 tickets. Any questions on that? Okay, again, it's not supposed to be a trick question. It's just there were 3 tickets I got, so I have 3 ways of winning. Okay, and they're all different. You can trust me on that. Okay, so now we got to find the denominator. Again, the 27 is what we're going to multiply by, but the number of ways of picking 5 numbers from 1 to 47 without replacement is very tough to do by hand. The good news is we don't have to do it by hand. So if you have it with you, I strongly recommend getting your calculator out. If you don't have it with you, I strongly recommend next webinar bringing your calculator so that you can follow along as I go. And your calculator might look slightly different. I'm using the TI-84 Plus. So I got to screen share again. So I'm going to do the new share with the calculator. Okay, so what we want to do is want to use our calculator to find the number of ways of picking 5 numbers out of 47 numbers. And the way you do that, again, follow along, you hit the math button. Must be important. Math is, pretty important. The more important number, by the way, is going to be the stat button. That's going to happen a lot. But for today, we're going to use the math button. And then we're going to use the right arrow until we get to prob. Stands for probability. Makes sense since we're doing probability. And then we're going to go, oh, wait, actually, sorry. Before I do that, I always forget. Let's quit this. The first thing you have to do is you have to put 47 because we're picking from 47 items. Then we're going to go math button and then go to prob. And then number 3 is NCR. Okay, N is the number that you're picking from. R is how many numbers you're picking. And C stands for choose. So we're choosing 5 numbers from 47 numbers. So that's why it's NCR. So I hit enter on NCR. And then we see 47, C, and then 5, because we're picking 5 numbers. Any questions on that? And then as always, you can hit enter or it doesn't do anything. Okay, so that is 1,533,939. Okay, if you remember, that was the number of ways of picking 5 numbers from 1 to 47. We also need to pick that mega number from 1 to 27. So now I'm going to type 153,3939, and then I'm going to multiply it by 27. And that is that's the number of ways of them picking numbers. So you'll notice this is a lot, by the way. This is 41,416,353. Any questions on that? So the probability of this winning is 3 over 41,416,353. So let's type that in. 3 divided by, and then it's 414,16353. And that's the probability that this Super Lotto Plus they call it, is a winning ticket. If I had to enter, I want to show you something that's important. Is the probability 7.24? What do you think? What do you think? Is the probability 7.24? Any thoughts? Maybe you can put in your chat box. What do you think? Is that the probability of winning of this ticket winning? I don't see anyone typing in. It's either yes or no. Probability of just guessing right randomly. Okay, there we go. Kristen's got the idea. So no, it can't be. 7.24 is never a probability. Probabilities can't be bigger than 1. You can't have more than 100% chance of winning. Does that make total sense? So I want to remind you that when you're using your calculator, when you see this E, that means we're using scientific notation. They don't use 10 to the negative 8 because then you wouldn't be able to tell that there's a 10 to the negative 8 because it would just see that 62310. It'd be really hard to read. So the calculator uses E for that. They call this scientific notation, but they use E instead of 10. So what that means is move the decimal place over to the left 8 places. So you're going to have 7 zeros and a 7. Let's see if you... so Christian, actually, it wasn't quite right. I think you lost a 7 somehow. I think that was just a typo, though, is my guess. I don't think you purposely removed a 7 out of it or for some mysterious reason. Okay. Yeah, by the way, if you want to talk, you got to kill the mute. So what it is 0.000000724, etc. Very, very tiny chance. Should I tell my boss to, send my salary over to charity? Probably not. I don't think I'm that confident, seeing that the probability is really, 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 really low. Any questions? Any questions on this? It does tell you, though, just an interesting thing. Because remember, if you buy one lottery ticket, there's a 1 in the numerator. It tells you if the lottery gets over 41 million, and you ignore things like taxes, which is hard to ignore, then it's a good bet. Okay? If you double it, then you're taking into taxes. Taxes are around 50% when you're rich. I don't know from experience. I just know from reading. I'm just a teacher. So that's how you tell if the lottery is good or not. So when the lottery, I always buy a lottery ticket for the class, but if the lottery ticket goes over twice the denominator, then that's the time I buy a ticket, because then it's actually worth it. Kind of interesting. Doesn't happen that often, but once in a while, it's worth it. And if I lose, the money goes to schools, which is always good. Any questions at all on this example? Okay, what I want to do is give you some more examples that I have a worksheet for. So let me reshare my desktop with the worksheet. That is right there. Okay, so now what I have is a few questions. First is you're going to pick a letter at random from the words Lake Tahoe Community College. So we have all these letters. You can think of throwing the letters Lake Tahoe Community College, put them in a bag. Then you're going to pick one. Got it? What's the probability the letter's a vowel? And by the way, just to make life easy, A-E-I-O-U is a vowel. Let's not deal with like sometimes other things. So A-E-I-O-U we'll define as a vowel. So sorry if you're an English major and you disagree, but for this one, I want to make life easier. So let's see if you can put in the chat box the probability the letter is a vowel. Again, this isn't too hard. It's not a trick question or anything, but you get to count. And it might help. L-A-K-E-T-A-H-O-E C-O-M-M-U-N-I-T-Y-C-O-L-L-E-G-E. That's 25 letters. Okay, so that's a little hint. We're going to need that 25 letters all over the place. Okay, so what's the probability that you get a vowel if you pick a letter? It's easy. So you should all put in your chat box, and hopefully you'll all get it right. You have to count. Yeah, doing that helps. Actually, fingers are great for counting. I have a special way of counting with my fingers. That's 5. 8, not quite. I think you counted wrong. 8 out of 25, 10 out of 25. All right, I think I better do it with you. Okay, I'm going to read along. A, E from Lake, then A, O, E from Tahoe, then O, U, I from Community, and then O, E, O-E-E from College. There's 11. So 11 out of 25, because there's 25 letters. Any questions on that? You all kind of have different answers, but Megan got it. Any questions at all on 11 out of 25 that Megan has it? Okay. By the way, this is the time to make mistakes. You don't have to feel bad if you got it wrong. What you should feel bad is if you got it wrong, you don't understand why you got it wrong, and then you didn't ask. Then you should feel bad, because you should be asking if you're confused. Okay, so next is what's the probability that the letter is an L given that it is not a vowel? See if you can figure that out. And again, just keep it as a fraction. When you do the homework, by the way, do what it asks. If it asks for a decimal, use decimal. If it asks for a fraction, use a fraction. Okay. All right, good, good. So we notice there's an L from Lake, a couple L's from College. That's 3 L's. And then notice that 25 minus 11 is 14. So there are 14 non-vowels. So 3 out of 14 is the probability of an L given that it's not a vowel. Okay. First half of the alphabet or a vowel. And just to remind you, there's 26 letters in the alphabet. A through M are the first 13 of them. What's that probability? So again, you're going to need to count. Takes a while. And there's a couple ways of doing it. You could use the formula I gave you earlier, or you could just do it. In this case, I think just doing it is a little easier. But I think there's one actually easier way of doing it, and I don't know if anyone's going to do it that way. Let's see what you get. Yeah, 21 out of 25. And I'm not sure, Nicholas, if you did it the easiest way, but let me show you the easiest way. You know that most of the letters are either first half of the alphabet or a vowel. It's a lot easier to count the ones that aren't. So if you just go through and look at the ones that aren't, L-A-K, those all are. T, and then Y, right? And then N and another T. So those four are not. So then if you use what's called the rule of complements, which means that take 1 minus 4 out of 25 gives you 21 over 25. That's probably the quickest way of doing this problem. Any questions on that? Okay. Let's look at the number 2. Now we're going to pick 2 letters instead of 1 at random, and this, I'm going to boldface this with replacement from Lake Tahoe Community College. Find the probability that both letters are letters of the word Monday. Does this make your head hurt? Let's see if you can find this probability. Okay. And I'll give you a hint. The first thing you should do is find out the probability the first letter is a letter of the word Monday. And a hint, the denominator will be 25. Okay, Kristen says 6 over 25. I think you counted wrong, is my guess. I'm not sure what went through your head, but that's my guess. Yeah, undercount. You missed a few. M-O-N-D-A-Y. So, for example, A in Lake Tahoe is, and then O is, there's another A here, O-M-M, those are all good. And this O is good. This N is good. There's a bunch. Okay, Megan, I think you missed one too. Okay, I count 9 of them. The A, the A, the A, the A, the O, the O, the M, the N, and the Y. I believe there were 9, right? Okay, so that's the first one. Now the probability that the second one is from the word Monday will also be 9 out of 25. Is that clear? Okay, even if you know the first one was from the word Monday, the probability the second one was from the word Monday will still be 9 out of 25. And what's the key word? What's the key word to know the second one? The second letter being the word Monday should be the same as the first letter of the word Monday and the first one. And there's a key word, yeah, actually not the word replacement, but the word with. Had I said without replacement, that'd be totally different. So it's word with, but I think you both got the right idea. But it's actually with replacement means that the probability, and let me write this down. So if it's independent, then the probability of, I'm going to write A and B, is equal to the probability of A times the probability of B. You can also say the probability of A given B is equal to the probability of A. You can also say the probability of B given A is equal to the probability of B. So all 3 of those are outcomes of being independent. And with replacement, you always get independence. Okay? Without replacement, you usually don't have it, but sometimes you do. You never know. Any questions on that? So because of that, what we can do is we can just take the 9 over 25 and we can multiply it by 9 over 25. Any questions on that? Which, by the way, is 81 over 625, but that's not important. What's important is that you know how to do the set up the question, because the rest you can use a calculator for. Any questions? Anybody lost? Do you agree this isn't that easy? A lot of little details, and you got to have the right strategy to get there. Okay, let's look at the next one. So probability the second letter is a vowel, given the first is a vowel. And again, we're using A, E, I, O, U as a vowel, as our vowels in the alphabet. So probability the second is a vowel, given the first is a vowel. This is actually easier, especially, let me scroll up a little bit because we already did the work. Actually, it wasn't there, but remember the probability letter was a vowel. If you remember, that was what, 11 over 25. That's a hint. So what's the probability the second letter is a vowel, given the first is a vowel? Let's see if you can type that in your chat box. Okay, I'm still waiting. All right, but I think Sonia, the thing about the Zoom is I can actually see. Let's see, Nicholas isn't typing. Okay, all right, so the key, there's a key word here. I'm not sure what Kristen, what your thoughts were about 5 over 11, but I understand Amanda and where you made a mistake. It's with replacement. So do you remember, if, just like the card, if I put it back in, the probability doesn't change. You don't have to do any recalculation. Probability the second letter is vowel is just still 11 over 25 because it's with replacement. It could be any of the letters again. We put it back in. So we took out a vowel from the box of letters, we put it back in, we re-shook it, and then we took out a letter, and it's still 11 over 25. Does that make sense to everyone? So definitely that with replacement makes a big difference. So it's just 11 over 25. Any questions on that? Okay, again, please ask if you do, because that's the whole point of the webinars, is to make sure that as you're getting confused about something that you can, speak up and I can help you out. Okay, so now, if you pick 2 letters at random without replacement from Lake Tahoe Community College, find the probability the second letter is an M, given the first is an L. So see if you can put that in your chat box. And what's the key word in the instructions? Yeah, without. So that changes everything when it's without replacement. So what's the probability the second letter is an M given the first is an L? Two out of, okay, not quite 22. Notice if you pick an L, we didn't pick all of the L's, we just picked one of the L's. These are a bunch of letters in a box. We pulled one of them out. Does that make sense? There's still a few L's in there. Yeah, it's 2 out of 24. So it's 2 out of 24. There are 2 M's. Hopefully you can count that. They're both in community. And once you've taken an L out, there's still a couple L's in there. You haven't taken them all out. There's 24 letters left. Any questions on this? So the answer to the part A is 2 out of 24. Any questions on that? Okay, let's look at part B. Part B takes a little work. The first letter is an O, or I want to highlight that, bold it, or the second is an A. So now you got to remember that little formula I gave you would have the word or. And let's see, I'll give you a minute or two, at least to get started. Let's see how you do. So again, put in your chat box when you think you got it. So the first letter is an O, or the second is an A. And write the expression. Don't put it in your calculator because it doesn't show any interesting meaning when you look at the final answer. More important is the expression that has the arithmetic in it. before the arithmetic's actually done. So I'll give you a moment to do this OR question. And as you're doing it, I'll remind you the key formula. Actually, there's two of them. Probability of A or B equal the probability of A plus the probability of B minus the probability of A and B. So you got to remember that formula. And then the second formula was the probability of A and B was equal to the probability of A times the probability of B given A. So if you're not using those two formulas, you're not getting it right. Let's see if you can do it. Okay, so 2 out of 24, 4 plus 2 minus 4 times 2. Not quite sure. So probability of A will be a fraction. Okay, that's 2 out of 20, not 2 out of 24. Okay, Kristen says 2 out of 25 plus 3 out of 25 minus 5 out of 25. That's close. Great start. Great start. The finish wasn't quite right. All right, looks like we're getting better. 3 out of 25 plus 2 out of 25, okay, which is correct. It might be a little confusing for everyone else. It's correct, but you're probably more likely right as 2 out of 25 plus 3 out of 25. But it's correct just because you usually do the M first, then the L. But that's okay. And then minus 3 out of 25 times 2 out of 25, almost. One little tiny, tiny mistake. And that's this without replacement problem. So when you're talking about B given A, when it's without replacement, if we're given if we're given the first was an L, gives you one fewer to pick from, because we now know it's not that first L that you looked at. So let's see if anyone can do it with a little fix. Yeah, 3 out of 25 plus 2 out of 25 minus 3 out of 25 times 2 out of 24. And that's perfect. Okay, it's correct mathematically. I think I'm going to type in the more meaningful, even though this is correct, because the M had, let's see, the M only had 2 and the L had 3, right? So since it was asked for the M first, so you're probably going to go to, given that the first is an L. Okay, maybe I'll let it happen because you're looking at first as an L. You're just kind of reading it sideways and let that one go. Okay, and then again, can I trust you that you all know how to put that in a calculator? It's just arithmetic. You know, literally you just type it in. So I don't really care. The answer is not very interesting. The answer is not very interesting, but we need to know how to do it. Okay, let's do the last one. What is the probability that both letters are E's? Actually, I think I'm going to skip this one because we don't have much time yet, and I want to get to contingency tables. That's the last thing I really want to do. So I have a new set of questions, and they're quick, but we have to do them. Okay. The contingency table below gives you the results of a survey from Tahoe residents asking them what market they shop at and what kind of car they drive. A survey participant is randomly selected. Okay, so here's a table that shows the outcomes of the survey. We had economy car, SUVs, sporty, and none. People shopped at Safeway, Raley's, or Grocery Outlet. Okay, pretend this survey was done a year ago. I don't know any of you guys are from Tahoe, but we have a new market in South Lake Tahoe that opened up within the last year. So I wrote this, I think, last year. Anyone know the market? Okay, smart and fun. But we're going to pretend this was done a year ago. Okay, so find the probability that a person shops at Raley's. The first thing we need to do is we need to get totals. So let's add up the Safeway numbers. So 35 plus 62 is 97, plus 12 is 109, plus 9 is 118. Okay. I'm doing this quickly. I'm just adding. I'm not doing anything fancy. 23 plus 55 is 78, plus 17 is 95, plus 7 is 102. Okay, and then the grocery outlet, 48 plus 14 is 62, plus 11, 73, plus 16 is 89. I did it really fast, so hopefully I didn't make any mistakes. I'll know in a bit. Okay, then 108 plus 118 plus 102 is 220, plus 89 is 309. So the total sample size was 309. It's an important number. Any questions? That's just writing down the totals. So now find the probability the person shops at Rayleigh's. And the idea is it's really easy. So if you're struggling, then you're probably not trying to make it easy. So what's the probability they shop at Rayleigh's? Yeah, 102 out of 309. I'm not sure. It's not 1 out of 102. It's 102 out of 309 because there's 102 Rayleigh shoppers and there were 309 in the sample. Any questions on that? Okay, next one. Find the probability that a person is a Safeway shopper who drives an economy car. Okay, that one takes a little bit of thinking. So it's actually quite easy. Yeah, it's 35 over 309. So I want to write down that is the probability. I want to write in symbols first. Safeway, I'll write safe, and economy. And there were 35 Safeway economy car shoppers divided by 309 total. These are really easy if you know what to do, but I will be honest with you, I know they're not easy because I grade the tests. And I always give a contingency table at least either on the midterm and the final, sometimes both, and it's not always that pretty. Okay, or usually, not always, but I usually give a test problem. So people make mistakes. Okay, if the person shops at grocery outlet, find the probability the person does not have a car. See if you can figure that out. Okay. Okay, good, good. So it's 16 out of 89. Notice that it said when you have an if question, the if is a given. So that's the probability of not having a car given their grocery outlet shopper. And that means that our denominator changes. We'll only look at the grocery outlet shoppers. So we have 89 in the denominator. And then of those grocery outlet shoppers, 16 don't have a car. Any questions on that? Okay, D, find the probability that a person shops at Safeway or drives a sporty car. This one you're going to have to do a little arithmetic. So if you can type this one out. And again, remember the formula for or. Or was a key formula here. So write the expression. I don't care about the true answer. I want the expression. The denominator is not going to be 118, actually. So it's an or question, not a given. Had it been if someone drives a Safeway, what's the probability they drive a sporty car? That would have been the Safeway sporty. That still wouldn't have been the 30, actually. I'm not sure how 30 came about, actually. I have no idea. But that 118 would have been right. But it's different. It's the or. So remember, let me type it in so I'm not seeing you all jump in at once. So we're looking at the probability of Safeway plus the probability of sporty minus the probability of Safeway or and sporty. Any questions on that? Now you might be able to do it. Now so you can put the expression in. Okay, let's see. Megan says 118 over 309. That's a good start. Plus 30 over 309. So that's the sporty cars. 12 plus 17 plus 11 is 40. Is that clear? So 12 plus 17 is 29, plus 11 is 39, and one more is 40. So I think you got the right idea. My guess is you just made an arithmetic mistake. Okay. And then minus 118 over 39 times 30 over 3, and that's not quite right. Okay, that's only true if they're independent. Okay, this is actually much easier than you're making it, it turns out. I think I want to put in the answer. So it's 118 over 309 plus, and again, 12 plus 17 plus 11 is 40 over 309. And then minus, now we want to see Safeway or Sporty. Safeway and Sporty, and there's 12 of them. So it's going to be minus 12 over 309. Any questions on that? So Megan, do you see why it's not a multiplication? That's only works if they're independent. Okay, it's actually easier than multiplying. It's just the 12 because that's how many that were both. Any questions? Any questions on this? Okay, so the next one, we have two more. I go a little over. Again, I promise you this is going to be a tough one. So I think we need to go a little more than an hour. Not a whole lot more. Probably another 5 minutes. And then I got to give you the secret word. Okay, are the events drives an economy car? And I need to be creative on the spacing so you can see. There. Are the events drives an economy car and shops at Raley's mutually exclusive? Okay, so first thing, if you don't know, I need to give you the definition of mutually exclusive. So A and B are mutually exclusive. I'm going to write ME for mutually exclusive if the probability of A and B is equal to 0. So, are they mutually exclusive? Are drives an economy car and shops at Raley's mutually exclusive? Is the question. So while you're thinking about it, let me type in kind of the work that needs to happen, the probability of economy and Raley's. What is that probability? The hint is it's easy. So what is the probability of driving an economy car and shops at Raley's? The hint is it's very easy. Think about how I did the other one. Okay, yeah, 23 over, not 102. It's an and, not a given. So, not 23 over 102. Yeah, 23 over 309. Okay, now the next question should be the easiest question of the day. Is that equal to 0? If you take 23 and divide by 309, do you get 0? No. So the answer is, so not 0, so not mutually exclusive. Any questions on that? Okay, then finally, are the events shops at grocery outlet and drives an SUV independent. So now you got to remember something I put in about 45 minutes ago about the definition of independence. There were 3 equations. You can pick any of them you want. Let me remind you, and I'll write them in again because they're important enough. Probability of, so independent means that the probability of A and B is equal to the probability of A times the probability of B. It also means that the probability of A given B is equal to the probability of A. It also means that the probability of B given A is equal to the probability of B. If you could show any of those are true, you're done, they're independent. If you could show any of those are false, you're done, they're dependent, they're not independent. So here's a question for you. We have the first, second, and third. Which is the hardest of the 3 in this case? Any thoughts? Because we could choose any, so no reason to be hard on yourself. Which is the hardest of the 3? Put it in the chat box and tell me. Which is the most difficult of the 3? One of them is harder than the others, actually. In this case. Not in all cases, but in this case. Any thoughts? At least you can guess. First, second, or third. Okay, good. The first one's the hardest because if you look at the first one, here's a probability here, there's a second probability, and there's a third one. So there's 3 probabilities to calculate. You see that? So the first one is going to be a little harder because the others only have 2 probabilities to calculate. Any questions on that? Okay. The given at shops at grocery outlet is going to be a little easier. So let's look at that. And that's because we are, and just in this case, because I already calculated the totals, just because I did the work for you. So let's do the probability of SUV given grocery outlet, GO. What's that equal to? What's the probability of SUV given grocery outlet? Okay. Actually, it probably doesn't matter. The second and the third are equally difficult or easy. So what's the probability of SUV given grocery outlet? Okay. Yeah. So SUV given grocery outlet. I think you read economy instead of. Yeah. There we go. Had a feeling, Kristen, you knew what it was. You just read the wrong one. Okay. So that's 14 out of 89. Again, any of you, if you don't understand, just because Christian got it doesn't mean you got it also or understood it. So please, ask me. Okay, what is the probability of just SUV? That's going to take a little arithmetic. It's not that bad, but what's that one? Yeah, 131 over 309. Okay, so we need to find out if those 2 fractions are equal to each other. So let's see if you guys could do better than last night's group. What is the easiest way of deciding if 2 fractions are equal to each other? See if you can tell me. Put in your chat box. And see if you can do better than last night. Last night, they all chose the hardest way. Let's see if you can choose the easy way. Yeah, and in particular, how do you make it into a decimal? Divide, and how do you do that? I don't see y'all typing it. Here's a hint. Use one of these guys. Okay, use a calculator. You don't have to do the fancy arithmetic. Last night they were all trying to do least common denominator and all kinds of other things. Okay, so the easiest way is stick it in your calculator and see if they're equal. So what do you get for the first 14 over 89 is a decimal? Stick in the calculator? Yeah, 0.42. And for 131 over 309, you get 0.53. And they're not equal to. So since the two fractions are not equal, the events are dependent. And dependent is the word for not independent. It's a little easier to write. Any questions on this example? Okay, so again, we're a little longer than I usually like, but again, this is a hard chapter. There's no way I can make this just an hour. But it's time for the secret word. Secret word is very simple. Or. Because we've seen the word or come up a lot, and I try to give you something that's in a highlight, and especially something that's a highlight that you might not guess if you don't watch this video. You probably would not have guessed that the secret word was going to be or today. Okay, so what I will do, as always, and I know always has only been 2 weeks now, but you'll see that, is I will hang out until there are no more questions, or until you're all gone, one or the other. And I'm trying to unmute, but it's not letting me. Oh, well, that's okay. And I think I want to, yeah, good. So if you have any questions, this is the time. And I unmuted everyone, so this is the time definitely to ask questions.
The only hard time I'm having with this chapter, with what you talked about today, is the independent. All those three options that I have to choose. I'm just a little confused. Like when you guys did that example, I understood how you got what you got, but I didn't understand like which equation that you chose and why you chose that one, if that makes sense.
Okay, so first thing, had you chosen the others, that would have been fine too. Okay. You would still get different fractions. So either they all work or none of them work.
So the one that you chose was the first one?
I chose, no, I chose the third one actually.
Oh, okay.
I chose the third one. And the reason, I could have chosen the second one, that would have been fine also. The first one, I would have had to do 3 calculations, you see? Probability B, probability of A. We would have had to do the probability of B and A, and that would have been 3 times the work instead of only twice the work. Okay? Sometimes though, the first one, like if you've already done the probability of A and you've done the probability of B, and maybe in, you know, like part A or B or something, then the first one could be easier. Do you see that? Mm-hmm. Or if you're given some of this, then sometimes the first one's easier. So whichever is the easiest, I will not dock you points if you use the wrong one as long as you're using it correctly. Okay? And I won't even say wrong one if you use the more difficult one, because there is no wrong one. Because they're all okay. Whichever one you use is great. But I didn't want to use the first one because that's the most difficult in this case. But it would have been fine. It just meant I would have had to go a little longer than 111. Any other questions?
If we're going for the independent, do we want to check all 3 of those equations, or is one good enough?
Definitely one is good enough.
So if one's true, all 3 are true always.
Exactly. And if one is false, all 3 are false always.
Okay.
Yeah, so it's all or nothing. And again, what you don't have to do in this class is understand why. I'm not going to make you prove that.
Okay.
But I do want you to know that if I ask you to find whether they're independent or not, there are 3 equations at your disposal. Pick one of them, check it, and if it works, then say yes, they're independent. If it doesn't work, then you say no, they're dependent.
Okay.
Okay, I'm going to say works mean if the equation is true. Other questions? Sonia, any questions? You look relaxed.
I was wondering if you might be able to scroll up on this worksheet.
Just tell me when to stop.
But yeah, back to the beginning. I just wanted to kind of.
Yeah, I didn't do all of this worksheet. I could only do so much. I decided to do some other stuff instead.
Oh, I see. Okay, yeah, let me read this. No, I think I'm good, actually.
Okay.
Practice will probably be the key now.
Practice is absolutely important. Don't assume that you watched me do it, so now you're good at it.
Right.
That's definitely not going to happen. You watch me do it, so maybe you understand the concepts, but without practice, you won't know when to apply what. Okay, and what's going to happen is you're going to get it wrong, and then hopefully you'll figure it out and get the next one right. Okay, and I want to mention a couple more things. I apologize for last week. I said that you can retake the online quizzes, and then your highest score will be the one. Well, I'm new to this system. We're using a new system. I wrote all the problems and I created everything, all the questions and the randomizations and stuff like that. But I didn't create the system, the back end part of the computer. And I didn't realize that, no, it doesn't allow me to change the settings so you can retake the quiz. So as a compromise, which actually makes it easier on you, but it means a little less practice for you because you'll be tempted not to look at the ones again. You're going to be able to redo any individual problem, whether you missed it or didn't miss it. And the highest score counts. But I will let you know that if you redo a problem, then your first attempt gets erased forever. Only the score stays. So your highest score will remain, but the problem is gone. So if you want to remember it, you need to write it down or take a picture of it because it'll be gone. And that's just part of this program. I wasn't able to, I literally spent hours trying to figure out the best way around the fact that it won't let you retake the whole quiz. And this is the best we can do, which is pretty good, I think. And you'll be happy with it. But that's just a note. So again, I apologize for making a promise and then not following through, but I think you'll like the compromise better than the original promise, probably. So sorry about that. And another one is, don't forget, Thursday, what must be done by Thursday?
Your initials.
Your initial post.
Yeah.
Initial post. Yeah. So don't forget that your discussion forum initial post must be done by Thursday. A bunch of the class, and again, I'm not going to mention any names, but a bunch of the class waited until Sunday for the first post, and that you lose points. And other people aren't going to be able to respond to your post. Okay. My recommendation is make sure that if you were another student looking at your post, that you would be able to answer it. If you can't answer it, then it may not be a good post.
Are you referring to the 2 truths and a lie?
No, that was last week.
Oh.
So for this week, it's post something that has 2 different types of charts. And you'll see under discussions, under week 2, you'll see that it's there.
Okay.
The 2 truths and a lie, I'm about 90% of the way done grading it. And the other one, I'll finish grading that one definitely by Thursday, maybe by the end of today. We'll see. And I'm going to work on it until it does. It takes hours, so I do my best.
But every week the discussion has to be done by Thursday, correct?
Every week. Yep. Every week the discussion has to be not done, but your initial post has to be posted by Thursday. Okay. And then your reply to someone else's post has to be done by Sunday. And make sure you read the instructions and read my sample post, because that will help you see what I'm looking for.
This is in the announcements section.
That's in the discussion. If you want, let me.
Okay.
Before you exit out of this, I'm sorry, Chris.
Okay.
Before we leave this page, is this page going to be somewhere where I can view this again and review this.
When you say this page, do you mean this video, this webinar?
No, I'm sorry. These questions that you had us practice on.
Okay, well, they're on the video. So they're there.
Video, you're gonna save this video, right?
And that will be on YouTube.
Okay, that's fine.
Yeah, if all goes well. When I hit done, it has to say it. I probably should hit done now. Let's see. Pause share. There's got to be a way to be hit done.
Okay, thank you, Dr. Green.
Okay. All right, well, thank you. And again, I'm here for more questions if you still have them. I don't have anything I have to do for 2 hours, so other than I'm going to grade your stuff. Okay. But thanks for coming. And if you have any suggestions about how you'd like the webinars to go, if something could be improved on, let me know. You can either do it anonymously or not anonymously. I don't care. But I'll be happy to make changes. This is for you.
Thank you. You're a lot of help.
Thanks, Larry.
Okay, thank you guys.
Have a good day.
You too. Have a great day. Okay, and just let you know when you're ready to leave, it's a, I think it says leave room or something like that. Leave meeting, maybe.
Oh yeah, this little blue button here.
Yeah.
Yeah. All right. Well, I'm going to spend probably the rest of the day sitting and going over the work I need to catch up on. So
You have a lot
really
of questions, too.
the time on your webinar, man. Thank you.
Okay, great, great. And Kelsey, I haven't heard from you, so my guess is you're going to say goodbye. So I'm going to say goodbye. I'm going to unshare. And stop recording meeting.